Hi, this is Stampder Podcast, where we discuss embedded Linux, IoT development, and anything else we might find interesting. Your hosts today are Cliff Brake and Kim Raj. Hi, Cliff.
Hi, Kim. How's it going?
Going very well. How are you doing today?
Yeah, doing well. Thank you.
Today's topic is technology trends, and specifically how unique they are or how they apply to embedded systems and development and technology in general. So, Cliff, what are your thoughts on the technology trends in general?
Yeah, so as we make decisions, as we build products and develop software, and we make a lot of decisions about the technology, the components we're going to use in our projects and in our products. And if we look at these technology pieces, they typically form a trajectory. They start out immature, and I kind of view it as a kind of a parabolic curve.
Hmm.
So they start out, they're immature, and they gain interest, and a lot of people start using it. And then they reach a mature phase where it's sustained and it's very healthy. And then most technology goes through a period of decline where people start to lose interest, and then it gets to a point where it's no longer maintained,
Hmm.
or in the case of a hardware component, it may not be available anymore.
Hmm.
So this is what I've been calling the trajectory, technology trajectory, and it's kind of a concept that I've been thinking about that may help us think about stuff as we make choices.
Hmm.
And anyway, that's one way I've been looking at this. I'm sure there's a lot of different angles you can look at
Yeah.
this.
Yeah. No, I think that's really well put. So, if you look at like modern, products, they are not one technology. They have integration, a collection of different technologies. Whether and they could be coming from different sources. And so things like processors or ICs or softwares, databases, build systems, you name it, right? So there are
Hmm.
um, a bunch of components that come in. So do you see that this technology trajectory trend is common across all of them, or are there any differences that we need to, or is it generally, tending to this curve?
I think it's probably more applicable in software because software is is soft. It can be updated over time, and the value increases over time.
Mm,
And hardware can go through revisions too. You
mm,
can have new models released with new features, but software in general is a lot more flexible in that you might deploy a piece of software on a hardware platform and update that software hundreds of times over the life cycle of your project or product. So I feel like this concept is probably a little more pronounced with software components just because we can deploy new versions with no additional cost, really.
mm. So just to paraphrase you a little, what I understood is that, say, it can be long or it could be short in terms of time,
Hmm.
but the technology trajectory trends are pretty consistent when it comes to. So, having said that, how do you describe the technology trends? I know you touched on, I know some of the terms you talked about, but could you kind of touch base on, the technology trends and the trajectory terms that you've used to describe this curve?
Yeah, so if you picture this curve as an inverted parabola, inverted parabolic curve, um, we start out immature. We have
Mm,
a rising slope, then we hit a mature phase where it peaks out, and then it starts to decline, and then there's what I call the dead phase.
mm,
And across this curve, I I drew a line which is what I call the usability threshold. So if you're a conservative company, you might wait a really long time to adopt a technology and then hold on to it until it's nearly dead.
Hmm.
If you're a more progressive thinking team, you may adopt technologies earlier and discard them earlier, so the slope of the line can even change.
Hmm.
Um,
So what I see is at the beginning of the curve, so the intersection point of, say, the usability threshold, um, your cost of investment into those technologies are probably as high as they are, in the immature state, tending towards the mature, and then probably the costs are again increasing when it goes into the dead phase after the decline phase. Um,
that's a good way to put it. The lower you are on the curve on either side, probably your costs are higher. Yeah.
mhm.
Mm-hmm.
Yeah. So could you kind of take an example and then describe this curve? How a particular technology kind of life cycle looks like or looked like in this case.
Sure. I think programming language is probably a good one.
Hmm.
15 years ago, if you wanted to program a um, high performance, say, cloud service, if you had languages like Java and Python and Ruby, but those are relatively slow. And if you want something a little more bare metal, you would program in C++. So that's the way Google and a lot of companies did things, and a lot of other people. And that was probably the mature phase of that technology.
Hmm.
But then as time went on, new languages became available like Go or Ruby. I'm sorry, not Ruby, Rust. And
Hmm.
there's other ones as well. But so Go gives you performance almost like C++. But initially, in the immature phase, there weren't many packages available. So it was a
Hmm.
good language, but maybe had some rough edges and not many packages. So it was a little more work to adopt. But as time goes on, the number of packages, especially for network related activities, is continuing to increase at a very rapid rate.
Hmm.
So at this point, as we're further up the adoption curve, or the trajectory, I feel like if I want to find a package, it's almost easier to find it in the Go ecosystem now than the C++ ecosystem.
Hmm.
Again, especially for network-related activities. So as we've climbed the trajectory, we're on the rising slope with the Go language, and the C++ trajectory is on the declining phase, I feel, for this type of task anyway.
Hmm.
So that's just one example where
Yeah.
you probably don't want to jump on C++ right now for a internet cloud service type task.
Hmm.
You probably want to choose something that is on the other side of the curve, like Go or Rust.
Yeah. So, if you think that this again, keeping on to the cycle, right? So, what are, like, say if you were using a particular piece of technology that is nearing that usability threshold, um, what are some of the burdens that you will carry, say if you were deciding on using one of the dead languages for your project today, or you name it, some other technology, then what are some of the burdens that one has to be worried about?
So one of them is just finding third-party packages that do things like TLS or
Mm,
web servers. There's continually new standards coming out, HTTP2, HTTP3,
right.
and these things keep progressing. MQTT, just all kinds of new protocols are coming out. So if you're on a language that is being phased out, these packages won't be available, and you'll be tasked with writing it all yourself. And that's a much bigger job than most of us can take on.
Mm-hmm.
especially those of us in small teams and so on. The
Mm-hmm.
other things you may run into, if there's security problems or you need support, there's just less people working with it, so there's
Mm-hmm.
just less chance you'll get the help you need.
Yeah, yeah. So in other words, you are just trying to basically say is in my mind, it's a you're signing up for more work, which you're not sharing with the rest of the community because of that rising trend is not there anymore.
Mm-hmm. And you could probably speak to the build side of things. I mean, you have a lot of experience there. Can you think of any
Yeah,
examples there that?
yeah. So I think build problems generally, what you see as um, like any other technology, build is also another technology that keeps evolving. And obviously, you retrofit some of it back into some of the ecosystems, but not all. And if you take some of the the older languages, cross compiling was hard, right? And you basically have ecosystems developed to do specifically cross compiling, and it's very pertinent in embedded space because most of it is cross compiling. But then you basically spend quite a bit of time doing this because those languages and tooling around those languages were not meant to do that. But then if you were to say choose some of the modern technologies with package management in place, so if you consider Go, consider Rust, they're all inherently cross-compiled languages. So what that means is all those difficulties that you had, you don't have them anymore. But if you kind of use uh, those languages like C, C++, you do have those issues. So definitely those are some of the advantages that evolving technologies bring in, and they are huge when it comes to your developer productivity and friction of getting your work done. So definitely those are very, very key pieces.
Yeah, and C++ and C, they were great languages in their time when you didn't have this huge package ecosystem,
Mm-hmm.
that you have to leverage today to get pretty much anything done.
Yeah.
And just having good build tools, like you said, and being able to cross compile and pull in packages easily without a lot of friction
Mm-hmm.
really saves a lot of time and,
Yeah.
and
So
pain.
this brings me to the next question is about value. So what's the sweet spot, so to speak, where you extract the best value out of this curve?
Yeah. So that's a good question. If you want to avoid all the pain, you simply move your usability threshold line up
Mm,
towards the peak of the parabolic curve,
mm,
and you adopt it when it's very easy, and you get off of it quickly
mm,
when it starts declining, so you don't experience any pain. But the
mm.
problem with that is you don't spend very much time on the curve.
Right.
You're catching a very small window of the overall life cycle of a particular technology.
Mm-hmm.
And that's the trade-off you make. If you want to avoid any work or any difficulty, then you'll also lose out on some of the advantages in the value that's being produced in that ecosystem. So
Mm,
value is one of the most important parts, because these technologies, these software components, they improve over time, and they're continually getting better, and this is always also adding value to whatever work you're doing.
mm-hmm.
So if you can leverage that value over time, it's value that's coming into your project that you're not directly doing, and that's just the nature of open source and
Mm-hmm.
So I feel like the value proposition is actually a bigger issue than even the pain proposition. It's kind of the positive way of looking at this
Right.
versus the negative.
Yeah.
And there's also value in getting in a little bit early because you can influence the direction things go. Once a project gets to the size of the Linux kernel, you have almost no chance of influencing the
Mm.
direction it takes in any significant way.
Yeah.
Whereas, back when I started in open source, 20 some years ago, the Linux community was small, and
Mm.
I was doing work in it, and it was a fun place to work,
Yeah.
and I could contribute meaningful work to it. But today, it's much bigger, and
Yeah.
it's not really practical anymore for small players.
Yeah. So essentially, there is an opportunity to engage, to become a contributor in and influence the project thereby at the beginning of the curve.
Mm-hmm.
But that's also an investment from you.
Sure.
Um, so it's basically, we talked about the cost. So it's a progressive cost at that point where you're investing in, which basically will yield value over a period of your adoption, period of curve to you.
Right.
Um,
And
I-
this investment could even just be using it and providing feedback.
oh
That's
yes.
that's a very valuable. Most people think of open source contributions as writing code, but that's really a very small part. If you look at
Hmm.
most open source projects, the actual code is written by a very small number of people compared to the number of people using it.
Yeah.
But
Very well said.
without users, you know,
Yeah.
we can't really make good progress either. So it's
Yeah. Yeah, and that's very important because I myself I go to some of the projects that I'm collaborator or contributor, and there are new users asking questions, and I go and try to answer them,
mhm.
uh, essentially enabling them to use the technology, and I think personally I think that's also a contribution, even though I'm not contributing code there. And in some cases, I'm just pointing to someone else, saying that, hey, would or tagging another user or contributor to kind of say, connect to this problem. So just connecting people in the community.
Mhm.
I think that's also a kind of contribution. Um, and I agree wholeheartedly that code is just one of them. All right. So, having talked about value, what is the best time to adopt? So, say, if I was looking at from a product point of view, and sensing there's different technologies, and my, architect has given me, we will be, needing X and Y and Z, and then how do you put that, decision metrics and say, well, these are the technologies we'll be using, and factor in the technology trend curve in there.
That's a hard question because
Mm.
it's every open source project is very different from the last one, and that's
Hmm.
part of the power of open source is it creates a culture that's just right for the task that needs done.
Hmm.
So you look at the Elm ecosystem and that community, and it's very different than the JavaScript community.
Hmm.
But they're both functioning very healthily. It's just completely different approaches and paradigms. And you have to make good decisions because if you jump on something that's hot and new, it could just die, if people lose
Mm.
interest very
Right.
quickly. So there is risk if you get in early. But I feel like you want to get in on the rising slope of the curve, when
Hmm.
when things are just taking off and it looks
Yeah.
healthy, but yet it's still small enough that you can participate, you can get interest, and with some things like the Linux kernel, that's obviously in the very mature phase right now. So, and we're all
Hmm.
going to use it. It's not really an option. But
Hmm.
where we do have choices, like programming languages and libraries we use, packages, that's
Hmm.
where these decisions come into play, and where we do have choices. So
Hmm.
yeah, I don't know, how do you make choices like that? Is it just gut feel, or do you have any more systematic way to do it?
Yeah, yeah. So I think gut feel is a good one because a lot of nerves end in your gut, probably
Mm-hmm.
more than what end in your brain. So, uh, but on a serious note, I think there is um, we do basically have to have, because technology, as you just said, trends might vary, and the nature is unique to each of those. Um, what I think is, if you have a system in place to evaluate them and continuously evaluate them, develop that system for yourself, where you can put the technology through and then get an assessment on how you see it in terms of the technology curve, um, will give you the best possible result. Because in this case, you are not influencing all the technologies. You never can.
Mm-hmm.
um, so at certain point, it's like you have to wade through, and it's look through the rising tides, and use that for your advantage. So um, there is no strict mathematical formula, I would think, but you have to have a process which is continuous. um, and because products will come and go, and they will come at certain point of time, and you have to take a snapshot of that time. And if you don't have the framework in place, if you don't have the process in place, then you would be reacting to the situation, and that is the worst thing you can do, because you would be under fire for the time, and you might make wrong decisions because you haven't done your homework. But you would be responding to it if you have that framework in place. That's how I see it.
Yeah, that's an excellent thought. It's not something you can jump into with no experience and in a week make a decision. This is a long term game.
Mm.
It's a it comes from watching the technology landscape over a period of time, getting a feel for it.
Hmm.
And I know we've talked about the idea of doing kind of demos or prototypes, and
Mm.
we'll probably discuss that in the future as a way. But it's definitely a long term thing, and it's a something you have to kind of be engaged in, and watch it. And one way I do that is we have a discourse forum set up for our Tempter community,
Mm.
and one of the ways I do it is as I see something interesting, I'll post it there and write a little bit about it and
Mm.
tag it. So it's kind of my online notebook for new technologies and kind of what's happening in the industry.
Yeah.
Um, so that's one little piece of my process. There's a lot of ways we can do this,
Yeah.
but you
And
have
I
to have
think,
you have to have a process. That's for sure. So
yes. And you mentioned about collecting this information on Tumblr community. I think it's very one more thing I learned about it is, when we are kind of like looking through a technology, we do have some confirmation biases and things like that, because at that point you are also at times emotionally invested in it, some to a certain extent. But if you keep collecting that information over a period of time and you grow out of it, and a decision point comes, you come back, you take a very objective look at it, and then you say, "Oh no, I was wrong about this back then, or things have turned out to be a little bit different," and you evaluate all that accordingly. So it's huge value at that point of time than it was probably when I was, creating that information at the first place. So I found that very, very useful for my own purposes as well.
sure.
All right. So these were some of the discussion points we had today, and I hope you found it interesting. So any parting thoughts, Cliff?
No, I it's an interesting topic, and I'm sure we'd like to talk more about it. So appreciate you listening, and any feedback's appreciated.
Thank you very much.
Okay, until next time, Kevin.
Hey, bye bye.